to introduce myself. I'm Navin. I work at SafetyCulture as an iOS developer. Work on the app called Spotlight. And today I'm going to be talking about code meet art. So it's good to have you guys here. And I've always been aware and consciously aware of a dichotomy that exists between code and art, and why code is not viewed as another art form like music, writing, poetry. And today I want to have a talk to actually reduce that dichotomy and show you how code is just another quirky instrument to create works of art. So that's going to be my talk today. So usually what happens is when I meet someone, they always ask me, so what do you do? And I'm like, oh, just a software engineer building apps. They're like, oh, okay. But what do you do for fun? I'm like, I'm sorry, I don't understand your question. And so I'm always like, yeah, but so when people ask you what do you do, and they're like, code, they really do not think that's like a fun part. So that's what I want to break today. And there's going to be a lot of live coding, so bear with me. I've kind of viewed art, and I've kind of broken it down. Trust me, I'm a developer, I know it. So there's broken it down into three parts. One is the entity. If something exists as is. Could be a tree, could be an emotion, could be an event. The second is you deciphering that entity, adding your perspective, and then producing an output or an art form. 3 steps. That's all, and that's how I view art as. So what I'm going to do is kind of go back into my childhood and try to show a perspective of what I grew up with. So a little backstory. I grew up to a lot of rap music, and Eminem was one of my favorite artists. Confession, still is. So what I'm going to do is I'm going to take his top 5 songs, break it down, and try to understand what is he actually rapping in his songs, and present it in a way where I think you guys would think it's cool. So I'm using a tool called Processing, which is a really cool open source IDE, and it kind of lets you write code in almost Java-ish, which is easy to understand. And it's also in JavaScript now, so you guys could choose either. So what I'm going to do is I have a text file of this top 5 lyrics. I'm going to see what are the words which keep repeating itself, and throw it into a dictionary and hash map. Simple algorithm, but let's see how it works. Cool. So I'm going to create a dictionary called word count. This is what's going to hold my value. There's a method in processing called setup. This is kind of like your main function, which gets called when this sketch executes itself. And this is where we're going to do most of our extraction. So what I want to do is first set the size of my canvas, which is as easy as this. Set the background color to black. And I'm just going to run it to show you guys that's it. So this is a 500 pixel by 500 pixel background black. Simple. So now let's actually extract the words. So what I'm going to do is create a string array. I'm going to call it lines. And I'm going to call this function called load strings, if I could. And I have a text file in the same directory called emi.nem.txt. There you go. So this would just extract all the words from the text file and give it me an array of lines. But I don't want an array of lines. I want like an entire string object which has all the words. So I'm going to call a variable called all words and actually split that entire thing with so every next line character will be broken down in its own array. And what I want to do at this point is convert it to lowercase so that I don't have any dependencies. And so I kind of know Eminem, and he talks about a lot of shit, like in terms of like prepositions and stuff. But I want to understand what he's actually talking about. And as an artist, I'm allowed to decipher what I want to be shown as an artwork. So I just have a really quick function here which just deletes most of these words, which I don't think is cool. So I created an array of all the words I want to eradicate, and I call it garbage. And this function just iterates through that array and finds out if it exists, and then turns it into an empty string. Simple. So let's see. So I'm going to say string clean words, and I'm going to say erase words So I'm going to just pass in all words, pass in the garbage. Done. So at this point, what I want to do is we have all the words which are eradicated. So now I want to break down each word as in its own array element. So what I'm going to do is I'm going to create another array, call it tokens. And I forgot what that. Yep, it's so split tokens is like, so what in the sentence, how do you want me to break these words up? So I'll be like, yeah, the sentence has got a space, break any word that's got a dot, a comma, semicolon, colon. I'm going to do an escape character, \n, and this. And that's it. So actually now, just to see till where we are, let me just print out tokens. Ooh, first error. Sorry. You're right. Yep. So we've broken down each of these words, and I have an array of all the words he's ever used. So the next final step is to iterate through those words, which I'm going to do. And so the in dictionary has a cool thing where it says word count dot has key, and I can just say it's got a token. Just word. Yeah. So if it has the key, and I'm going to say increment by the token. And if it doesn't, I'm going to set a new key. So say token and 1. Does that make sense? Cool. So now that I have a dictionary of this, let me just print it out so that you guys can understand at which point we are at. So yeah, these are all the words. He says mom 2 times, boy twice. Wow, this must be an OK song. So could be and all these things. So let's actually draw it. Look pretty cool. So the final part, what we're going to do, is actually render this to the screen. So the way we're going to do that is I'm going to do the same thing. I'm going to iterate through all the words in string. I'm going to call it word. In the word count dot keys. Right. So I'm going to create a variable called x, which is going to be a random variable where I want to draw the text between 0 and the width of the screen. I'm going to create another variable called y, height of the screen. I want to get the size of the text. So this is get what's the count. That should be get, yeah. And set my text size to the times it repeats itself. And draw my text. Now text takes 3 parameters. One is the word, what you want to draw. And second is the x and y coordinate. That's it. Boom. Now 1 second. Let's make it look pretty. Instead of having a 500 by 500, let me make it full screen. There you go. These are all the words he actually says. And you can actually see that he says you, talks about you a lot, talks about me, drops the F-bomb quite a lot of times there, says God, says man. So if I just showed you the dictionary, the way I chose to represent it actually now makes sense. If someone asks you, is that just a random picture of words, you'll be like, no, that's the amount of times. The size of the text depicts how many times an artist mentions that in his song, and the way it's arranged is just in any random order. So I think that's pretty cool. So that's number 1. Second is, let's see if I have another text file, which is top 5 Elton John songs. And it still works. Now, what does Elton John talk about? Oh, talks about crocodile. I think that's because of the Crocodile Rock song. And honky. Oh, he talks about a lot of crazy things. Oh, what else does he talk about? Yeah. Oh, he talks about man, so that makes more sense. That makes, Elton John. So, yeah. That's so cool. All right. So this is one part, and the second part is really cool. So what I want to go through is try to teach you how to draw a simple circle in processing, but this takes a bit of math, but just hold on, and I'm trying to explain it in a simple way. So what I want to do is try drawing a simple circle for you guys, and then we can work on things from there on, and this is really cool. So a circle, if you look at math, is a locus of a point moving around in a fixed radius, and as the angle increases, and that's all it is as a circle. So what I'm going to do, I'm going to depict the same thing in processing. So I'm going to create a variable called theta. That's going to be the angle. I'm going to call a variable called radius. Same thing, have a void, set up. I'm going to initialize my variables to 0. I'm going to set an arbitrary radius. I'm going to set my size of my screen. Set my background color to 0. And yep. So there's another function in processing which is quite cool. It's called the draw function. So draw function gets called for every time the screen refreshes as a refresh rate. So this will probably get called, like, if it's my screen refresh rate of 60 frames per second, it's going to call 60 times per second. And it's a really cool function. So what you're going to do is, since processing the coordinate system, if you take this as my canvas, 0, 0 starts from here. And we don't want that. We're like normal people. So we'll move it down to the center. And the way I do it is just like divided by 2 and height divided by 2. And yep. So I have 2 functions here, which is just creates an x coordinate and a y coordinate based on the sine of the angle. Now, if you do a bit of Cartesian geometry, every point on a circle can be represented by the sine. The x coordinate can be represented by the cos of the angle, and the y is represented by the sine of the angle. And when you change the angle, it always repeats itself, and that's also called a sine wave. Don't worry about it. But so this is what all it does. So I just create a function. It returns the cos of that and sine of that. And I'm going to hold on to those variables. I'm going to say x is equal to into the radius, because we need to multiply it by the radius. It's like your r sine theta formula. And y is equal to ypt theta into radius. Boom. All right. So same things first. Stroke. I'm going to set a stroke weight to draw this point. That's just like my, what's the thickness? I'm going to set it to 3. Set my stroke color to 255. It's going to be white. And draw my point at x, comma, y. And that's processing's internal function draw point. So, and since we have theta, I need to say theta plus equal to 0.1. So I'm going to increase it every time it calls it to 1. Oh, something went wrong. So, yep. Oh, sorry. It's too small. It's too small. Let's make it 50. There you go. So because it's like it keeps calling itself, so it keeps repeating. And here's where it gets really cool. Now, if I have that, and if I want to make a spiral, all I need to do is just do the same thing for radius. Oh, come on. This is going to improve by 0.3. And there you go. You get a spiral. So every time it draws, it would increase itself. So, and that's how you make custom screensavers if you're bored. And that's my day job. OK, so here's the cool thing. So if I just keep messing with these things, I really get cool patterns. And the reason I'm taking you through this is because it kind of like segues into the next part of the talk. So if I just add another angle, which I have no idea what's going to happen, but it starts to make these really cool patterns. So you guys saw what happened. And the next part is an idea I had a long time ago, is where what if you broke up a song into its individual frequencies? And when you break up individual frequencies, you have these bands which are falling into different sectors. Each of these bands can be now mapped to your C chord, your G, E, A minor, and all of your general music bands or chords or musical notes. And if you map each musical note to a color and depict it, and that was my idea, and that's what we're going to do. So the thing is that the code for this one is fairly long. So what I'm going to do is just run you guys through a code which I already have. So who knows anything about Fourier transforms? Oh, sweet. OK, we're not going to get excited and bore the rest of you guys. But so what I'm going to do is there's a library called the Minim library, which is a sound processing library. So I'm going to listen to the sound coming in through my microphone, kind of detect what frequency it is, and then try to map it out to a frequency band where C or D or E minor falls under, and then map each of those frequency bands to a color, and then put a dab of parametric equations to it, and you get like the most beautiful thing you've seen. So I'm serious. So OK, I'm just going to go through the code. So this is a library which does it, instantiated. I've got a variable which holds the note, int, stuff. Theta rate is what you saw from the last time. Now, sample rate is the amount of samples it takes. Because it's an analog signal, I need to break it down and tell you how many samples I need per second. So that's my sample rate. The max frequency is that, if you know Fourier transforms, is that it works across like a frequency spectrum. And the frequency spectrum is always going to be half of your sample rate. That's if you didn't skip school in engineering. You would know that. So the second is I'm going to hold frequency and an array of colors. So this is basic stuff. Just set the full screen, background to 0, initialize my minim library, blah, blah, blah. Set up my FFT. So this is get line in is where it starts to listening to my microphone. And I'm going to convert it into a mono channel to make it easier and pass in my sample rate. And also, I'm going to look at the right channel for this one. Just going to choose one arbitrary channel. So here, there's a function which I call as find note. This is where all the magic happens. So it just like looks at the right channel, iterates through all the frequencies, finds out what's maximum frequency. If you know Fourier transforms, it knows that it converts a signal from time domain to its frequency domain in the frequency spectrum, blah, blah, blah. Anyway, this is the part I told you I wouldn't talk about. So, and then there's a formula I've ripped off the internet and how to convert a frequency into a chord. And that's this. And since every chord has 12 octaves, I need to do a modulo of 12, blah, blah, blah. At the end, this spits out a color of everything. Now, let's run it. So I'm going to play a song and see how it maps it out. That's it. So each of the dots is actually that particular frequency at that point in time. And so this is, and it kind of like just maps the color. So this is in a way where you actually see a song visually represented. And it might seem random to you, but then when someone actually knows that each of this frequency, it kind of adds that one layer of perspective, and it kind of makes a really cool piece of art. So the second thing I want to do is just change a bit to make this really cool. So if I just divide this by 3, and I just found this out by mistake, and it makes this really cool pattern, what you need to see. I'm going to change the song, because we're not boring. What's the next song? I love this one. As you can see, that code is just another canvas to build things and to represent yourself. And just worry about the story, what you want to say, and don't think about the language. No pun intended. Thanks.